right under our feet, beneath the solid ground we walk on every single day, there's this raw, incredible power just waiting. So today, we're diving into the planet's fiery architects, volcanoes. These are the very forces that both build our world and sometimes have the power to destroy it. And to really get a sense of their true impact, we've got to go back to one fateful day.
Picture this. It's November 13th, 1985, in the town of Armero, Colombia. It's just another Wednesday. Life is going on as normal, and absolutely no one has any idea of the catastrophe that's literally just hours away.
What happened that night would go down in history as the Armero tragedy. And the cause? A nearby volcano. A giant that everyone thought was dormant, just sleeping peacefully. But it was about to wake up, and the consequences were going to be devastating. The human cost was just staggering. In a matter of hours, an entire city was buried. While exact numbers are always tough to pin down in these situations, the disaster impacted well over 50,000 people's lives, with tens of thousands perishing that night. The town was basically erased from the map. The culprit here was the Nevado del Ruiz volcano. And it wasn't just a classic lava eruption. The heat from the eruption instantly melted glaciers at the summit, triggering these massive, fast-moving mud flows called lahars that raced downhill at 50 kilometers an hour, swallowing the town whole. It was a horrifying reminder of their power. So what exactly is this incredible force of nature we call a volcano?
Well, let's start with the name itself. The word volcano actually comes from Vulcan, who was the ancient Roman god of fire. Yeah. They thought eruptions were happening because Vulcan was down there forging weapons for the other gods. A cool story, but of course there's a little more science to it than that.
At its most basic, a volcano is really just a rupture in the Earth's crust. You can think of it like a safety valve for the planet, an opening that lets all this superheated material from deep inside escape to the surface. And that stuff has a special name. It's called magma. This is a sizzling hot mixture of molten and semi-molten rock that's found miles beneath our feet, deep in the Earth's mantle. It's just sitting there, simmering under unbelievable pressure and at incredible temperatures. But, and this is the key part, the very moment that magma bursts through the crust and flows out onto the surface, we give it a new name: lava. So the distinction is super simple, right? It's all about location, location, location. When it's underground, it's magma. The second it hits the open air, it's lava. That's it. That's the only real difference. Okay, so what is it that forces that magma up to the surface in the first place? What's the trigger? Well, the answer lies in the immense pressure building up deep inside our planet and in the slow, constant dance of the Earth's tectonic plates. It usually happens in one of two ways. First, you have constructive boundaries, where two plates are actually pulling apart from each other. This creates a gap, a perfect pathway for magma to rise up and fill the space. Then you've got destructive boundaries, which is where plates collide. One plate gets forced down or subducted under the other one. As it goes deeper, it melts, turns into magma, and all that new pressure forces it right back up to the surface as a volcano. But here's a fascinating exception to the rule. Not all volcanoes pop up at the edges of plates. Some, like the ones that created the beautiful Hawaiian Islands, form right in the middle of a plate, over what we call a hotspot. Just imagine a giant blowtorch from deep in the mantle that's fixed in one place. As the tectonic plate slowly drifts over it, the hotspot just melts a hole right through it, creating a whole chain of islands. Pretty amazing, right? So if most volcanoes are caused by these plate boundaries, that leads to a really obvious question: where on Earth is most of this action happening? Turns out the vast majority of it is concentrated in one enormous, incredibly active zone. Get this, a staggering 90% of all the Earth's active volcanoes are located in a single region. It's known as the Pacific Ring of Fire. And this map just shows you the sheer scale of the thing. The Ring of Fire is this 40,000-kilometer-long horseshoe-shaped path of intense seismic activity. And it's so active because the massive Pacific plate is constantly grinding against, colliding with, and sliding under all the other plates that surround it. It creates the absolute perfect conditions for most of our planet's volcanoes and earthquakes. But here's the thing. Not all volcanoes are created equal. They come in all sorts of shapes, sizes, and you could even say personalities. Geologists usually break them down in two main ways. First by their activity, and then by their structure.
Okay, so first up is activity. This one's pretty straightforward. You've got active volcanoes, like Mount Etna in Italy, which are either erupting now or have done it pretty recently. Then there are dormant volcanoes. These are the sleeping giants, like Krakatoa was before its massive eruption. And finally, you have extinct volcanoes, like Kilimanjaro, which are considered geologically dead. We don't expect them to ever erupt again.
Then we can classify them by their shape. Composite volcanoes, or stratovolcanoes, are those classic steep-sided cones that we all picture, built up over time by layers of sticky lava and ash. On the other hand, you have shield volcanoes. These are much wider, with really gentle slopes, formed by layers and layers of thin, runny lava. They kind of look like a warrior's shield lying on the ground. So we started this journey with the absolutely terrifying destruction of our marrow. But is destruction the whole story? Is that all volcanoes are? Or is there another side to these fiery mountains?
The destructive side is, well, pretty obvious and undeniable. Eruptions can blast enormous amounts of ash and harmful gases into the atmosphere, affecting global climate. They can contaminate water supplies, wipe out crops, and cause some serious long-term health issues for anyone living nearby. But, and this is a huge but, for all their destructive power, volcanoes are also incredible creators. That volcanic ash that can be so dangerous, it also breaks down to create some of the most fertile soil on the entire planet. They build entirely new land, like the Hawaiian Islands, from scratch. Plus, they give us clean geothermal energy and provide scientists with a priceless window into how our planet actually works. Which leaves us with this final question. Are volcanoes a force of destruction, or are they a source of creation? And the real answer, of course, is that they are both. They are this powerful, constant reminder that we live on an incredibly dynamic planet, one that is always changing, always shifting, and constantly remaking itself from the fire that burns deep within.